Hi everyone! In this video, we will solve an example problem in Chapter 7, which is about the refrigeration cycle. A thermoelectric refrigerator removes heat from the refrigerated space at -5 degrees Celsius at a rate of 130 watts and rejects it in environment at 20 degrees Celsius. Determine the maximum coefficient of performance this thermoelectric refrigerator can have and the minimum required power input. So based on our problem, a thermoelectric refrigerator that operates at specified conditions is considered. So the coefficient of performance, which is the maximum and the minimum required power input, are to be determined. So before we proceed in finding the problem, we will identify first our given. So we have here -5 degrees Celsius as our low temperature, and since this must be expressed in Kelvin, so we will add 273 Kelvin. And for our high temperature, we have 20 degrees Celsius, which is also expressed in Kelvin, so we will add 273 Kelvin. And now we will have the high temperature of 293 Kelvin. And also we have here 130 watts as the rate of low heat. So the maximum coefficient of performance of this thermoelectric refrigerator is the coefficient of performance of a Carnot refrigerator operating between the same temperature limits. So the coefficient of performance, which is the maximum, is given by 1 all over the high temperature over the low temperature minus 1. So plugging in the values in this equation, we will have 1 all over 293 Kelvin over 268 Kelvin minus 1. So this will result to the maximum coefficient of performance, which is equal to 10.72. So let's proceed now in finding the minimum required power input. So given the equation, the minimum required power input is equal to the rate of low heat all over the maximum coefficient of performance. So plugging the values in this equation, we will have 130 watts over 10.72. So plugging this in calculator, we will now have our minimum required input, which is equal to 12.1 watts.